Hello everyone. Um, my name is Yash, and if you're someone who has been watching, as you can see, the situation hasn't changed much. The audio quality is going to be not good for a while. But yeah, the point of these streams was never the audio quality. If you are here, you are not here for the audio quality. You're not even here for like the instruction. You are most likely here because you like to see people fail at what they want to do. Really. For those of you who are new, and most of you are new, almost all of you are new. Not a lot of people are watching these videos, but the, my name is Yash, and the, I'm someone who is interested in learning data science, and due to a lot of reasons, variety of reasons, some of which were really my fault, my bad habits, procrastination, lack of discipline, just general laziness, and certain situations, certain uh, health concerns that happened within my family. That was the reason why I couldn't build up a momentum, and that was the reason. I would spend like a day or two, but then I couldn't do it consistently, and then I would forget everything. So these streams are really a way for me to build consistency. If I have to make a video, I have a reason to sit down and do this, right? So that's the primary reason, and part of the motivation to do it is also, in my mind, I think I can't be the only one who is struggling with procrastination and general lack of motivation, laziness. I can't be the only one. Those things don't come naturally to everyone, and if you are someone like me who's struggling with this is, if I can achieve, then I can be an example that those odds are not something you can't overcome. It might not be easy for people like us, who have a problem sitting still, and who have a problem not being lazy. But yeah, if I can be an example for you, that would be awesome. So this is what we are going to do. We are trying to learn SQL or SQL, as some people call it, for data science. And last time we learned group by statements. If you're someone who didn't watch it, you can go and watch it. We learned group by statements. We learned how they work. We also learned the having function in the SQL, and so today we are going to learn joins. I don't know what it is. Like, up until now, I at least had watched parts of it. I don't have a clue of what joins is. So this is what we are going to do. Hopefully we learn. So let's get started. In this section, we will discuss how to combine tables in our database. Basically, that would be joins. Okay. So, like, if there is some data that is common between two tables, I think that is what that means. Statement. Sometimes joins can be tricky for beginners. I mentioned throughout the next lecture Venn diagram for joins. So, if you want to more resources after reviewing the lectures, check out the following helpful links. Okay, let's do that.
Welcome back, everyone, to this section on joins. So in this section of the course, we're going to discuss the various types of joins that are available to us with PostgreSQL. And really, a join, at the heart of it, just allows us to combine information from multiple tables. And let's take a quick peek at what we're going to learn in this section. We're going to start off this section by quickly discussing the as clause, which is a really useful clause for creating an alias. That is to say, it just allows you to rename a column whatever you want. Once you understand that, we'll move on to joins. So we're going to discuss different kinds of joins, such as inner joins, outer joins, full outer joins, unions, and more. So there's things also like left joins and right outer joins, etc. So lots of stuff to discuss here. We're going to start off with the simpler join types and then move on to the harder to understand or more complex join types. But overall, once you understand one type of join, the mental leaps required to understand the other types of joins isn't too bad. Okay, and then we'll end this with some challenge tasks. Alright, so now that we understand what we're going to learn in this section, let's move on to the next lecture. I'll see you there. Welcome back everyone to this lecture on the as clause. Before we learn about joins, let's quickly cover this as clause or as statement, which allows us to create an alias for a column or result. And what we mean by alias is just an alternative name. Let's see the example syntax for this. This is actually quite simple. Instead of just selecting a column from a table, we say select column as, and then we decide on a new name to display in the data output. We can also use this on functions on a column. So we can say something like select column, and then have that, instead of displaying as sum of that column in the data output, instead have it display as new name. Let's see some examples. So this is the way it classically works, where we say select customer ID from payment. And notice that the column name is the same in the data output below. We see customer underscore ID. Now let's see what happens if we were to use the as statement. So here we're saying select amount as rental price from payment. So notice here, instead of having the output reported as the amount column, instead we decided to give it an alias or rename it as rental underscore price. And maybe this will be easier for some other analysts to read when we actually show them our SQL query results. So really here, it's just for readability on the data output. And this starts to make sense, especially when we perform functions on a column. For example, select sum amount as net revenue from payment. And instead of having the output just say sum of the amount, here we can clarify it with an alias as the total net revenue from the payment table. So essentially, in net revenue, we've made around $61,312. Now keep in mind, the as operator gets executed at the very end of the query. And this is where a lot of students, especially beginners, get confused. That means that we cannot use the alias inside of something like a where operator or a group by call. I'm going to walk through an example of as operator gets executed at the very end of a query. And this is where a lot of students, especially beginners, get confused. That means that we cannot use the alias inside of something like a where operator or a group by call. And I'm going to walk through an example of trying to do that and having it show an error, because a lot of students get confused on that particular notion. You essentially only get to use that alias in the select statement. Anywhere else, it's not actually going to be valid. So let's head over to pgadmin and walk through an example of that. Okay, here I am at my query editor. What I'm going to do is say select, and we're actually going to say count the amount from the payment column. So if I run this, notice I get back just count as my output. And
okay, so let's do this ourselves. Payment. Oh, sorry. Select payment. Staff ID is equal to 2. I don't think this will work because this new color came. Yeah, I definitely didn't think. Okay, this is. I think this is what it's called. So for those of you who didn't watch, there are not a whole lot of people that watched, but basically this is, this is the staff. There are only 2 staff IDs. This store is basically going out of business soon because there are only 2 staffs, and the one staff ID is 1, the other staff ID is 2. So that's why I was just making it interesting for myself. So when he said that as can't be performed before where, and we did it, and so but I did want to perform a function using a where statement just to make it interesting for myself, because the basics we have, I think it's
and if I just see this data output without any regards to the query, it's pretty unclear what this is actually counting. So maybe I want to clarify this using an alias. So I can say as, and counting the amount from the payment column is the same as asking how many transactions have occurred. So I can say number of transactions, run this, and now I see that the data output has been renamed to be num_transactions. And recall, with count, you can always just pass in anything here, such as an asterisk, and that will be the exact same thing. So here, alias. Okay, now let's imagine we were going to do a group by statement. So let's do the following. Let's say, select the customer ID, and then some amount from payments, and then I'm going to group by customer ID, essentially showing how much each customer actually has spent. So I run this, and I get back the customer ID as well as some sum. However, if I'm looking at the data output, maybe it's not super clear that this sum happens to be their actual expenditure, because I don't see a $sign here anywhere, and unless I actually get to read this query and understand the thought process behind it, The data output results don't specifically tell me that this sum happens to be their total spent. So I can simply say as total spent, and notice I do this directly after whatever column or function result I want to rename, and then I run this, and I get back here in the data output total spent. Now here is where I really want you to focus, because this is where beginners often make a mistake. Let's imagine that I wanted to clarify on the sum amount. We already know I can do something like this. Having sum amount, and let's have it be greater than 100. And we actually did pretty much this exact same query, and I'm going to remove as total spent. So what am I doing here? I'm doing the exact same thing as before, except after I've done the group by and calculated the sum amount, I'm going to do an additional filtering using having, where sum amount is greater than 100. So I run this, and notice now my sums are all greater than 100. And now I'm going to use again my alias to just clarify that as total spent. So I run this, and now I get to see total spent here. Unfortunately, this alias gets assigned at the very end, which means I cannot do this. And this is where beginners try to do this a lot. They'll say having total spent greater than 100. And if they run this, you get back an error. It'll say column total spent does not exist, which at this stage is true. Total spent is only going to exist at the very end at the data output. So because an alias gets assigned at the very end, you cannot use it in something like a where statement or a having clause. Unfortunately, you have to go back and choose the original, either column name or the original function. So we'll have to say having some amount greater than 100, and we see back these results. So keep that in mind. These aliases get assigned at the very end, so you can't use them to filter by. So I'm going to show you another example of this. Let's just go ahead and remove group by and having sum, and we'll just say amount. We run this. So here are all the customer IDs. Notice there's repeats as well as the amount. Now let's imagine I wanted to qualify this for amounts greater than $2. Well, I could say from payments, then where amount is greater than 2. So I run this, and now notice I got rid of all those 199 transactions. Now if I happen to use an alias on amounts, so we'll say as new name, I run this, notice new name is now on the data output. Unfortunately, I cannot do this. I cannot say where new name is greater than 2. If I run this, I get the same error as before, that new name does not exist. So again, just to clarify, these aliases get assigned at the end, and unfortunately, you can't use them in the where clause or the having clause to filter by. Instead, just think of them as being used in the data output. And you'll have to use the original column name if you plan to do any filtering or comparison operations on it. All right. We'll say as new name, I run this, notice new name is now on the data output. Unfortunately, I cannot do this. I cannot say where new name is greater than 2. If I run this, I get the same error as before, that new name does not exist. So again, just to clarify, these aliases get assigned at the end, and unfortunately, you can't use them in the where clause or the having clause to filter.
So now we will learn about inner joins. I don't know jack shit about inner joins. Don't know jack shit about related to joins or SQL.
Welcome everyone to this lecture on the inner join. There are several types of joins, and in this lecture, we're going to go through what I think is the simplest join type, which is an inner join. And typically when students are learning about joins in SQL, they always start off with the inner join because it's the easiest to understand. First off, what actually is a join operation? Put simply, joins allow us to combine multiple tables together. Now the main reason for the different join types is to decide how to deal with information only present in one of the joined tables. So let's begin by imagining a very simple example. Let's say our company is holding a conference for people in the movie rental industry. So before the conference actually starts, we're going to have people register online beforehand. And the registration is simply just providing their name, and we'll keep track of people as they register. And then the actual day of the conference, they're going to come in and log in through an iPad with their name. So after the conference, we end up having these tables. So we have a registrations table as well as a logins table. The respective ID columns indicate what order they registered or logged in on site. So we can see in the registrations column we have Andrew who registered first, then Bob, then Charlie, then David. And then we have logins with Xavier, Andrew, Yolanda, and Bob. For the sake of simplicity, we're going to assume that in this little small universe, all the first names are unique. So there are not two Andrews, there's not two Bobs, every person has a unique name. Now to help you keep track of the different joins, since we're going to be using these example tables throughout this section of the course, keep in mind that the registration names, first letters, go A, B, C, D. And if you take a look at logins, the two outstanding ones that are not in the registrations are Xavier and Yolanda, basically implying that they forgot to register but still showed up the day of the conference. So what does an inner join do? An inner join will result with the set of records that match in both tables. So the situation we have right now, with the set of records that match in both tables. So the situation we have right now is, in the registrations, we had Andrew, Bob, and Charlie, and David register for the conference. However, the actual day of the conference, when people were logging in, we only had Andrew and Bob show up that actually registered, and then Xavier and Yolanda, who forgot to register, they came in on site and then logged in. And keep in mind here that it looks like Charlie and David registered but didn't end up showing up to the conference to log in. So we have that discrepancy there of Xavier and Yolanda in the logins table and then Charlie and David in the registrations table. So where do we actually have a match in both tables? Well, we have Andrew and Bob. Andrew and Bob are the only ones that both registered and logged in the day of the conference. So an inner join is going to be able to join these tables together for records that are a match in both tables. So when we're talking about an inner join, we're only looking for the set of records that happen to be in both tables. And in this case, that would only be Andrew and Bob. So what's the actual syntax for this? Well, we can say select and then whatever columns you want, but in this case, we'll keep things simple by selecting all columns. And we say select all the columns from table A and then inner join with table B. And then we provide what we're actually matching on. So match on table A column is equal to table B dot column match. So what does that actually look like in practice? So if we color code this and think of the tables as Venn diagrams, and if you look up SQL joins on Google Image Search, you'll see a ton of Venn diagrams. So a lot of people like to think of it this way. If we see here that we're selecting from table A, inner joined on table B, where table A column match is equal to table B dot column match. So we're essentially saying grab table A and then grab table B, and because it's an inner join, only grab the rows that happen to be in both table A and table B. And we have to actually join these tables on a particular column, such as the name column that we saw in registrations and logins, because we know the names are unique over this small universe of people. There's only one Andrew, only one Bob, etc. Now, something to keep in mind, especially with an inner join, is notice that this Venn diagram essentially is only filled in the crossover middle. Essentially stuff that can be found in both of these circles, table A and table B. Because of that, inner join is essentially symmetrical, which means if you select from table A and then inner join table B to look like this, select from table B, inner join on table A, you would get the same result. So getting from table A and then joining on table B is the same as getting from table B and then inner joining on table A. Keep in mind this is only true for an inner join in this particular case. So switching around the orders here, even switching around the column match order, doesn't really matter for an inner join because it's the same regardless, because it's a symmetrical Venn diagram. So let's actually work through this and what would actually happen in a more realistic situation with the example tables. Here we're going to say select all the columns from registrations, inner join, logins. So that's essentially saying take registrations table and then perform an inner join with logins, seeing the rows that happen to be in both registrations and logins. And then we have to decide what column we're actually looking at in order to perform this inner join. And in this case, we'll do it on the name. We'll say on registrations.name, so it's the table name dot and then the column name is equal to the table name dot column name, so logins.name. And keep in mind, you could swap any of these orders around because it's an inner join, it's symmetrical.
Let's try this, right? So let's go like there is customer table, there is payment table, okay, so like isn't equal to, and that's why it's doing this. Maybe that's why it isn't doing this, because the customer IDs are different. Well, that doesn't make sense. The customer ID should be the same, right? That doesn't make sense. Let's see. Maybe I haven't understood it fully.
It doesn't really matter if we're saying select from registrations, inner join and logins, or select from logins, inner join on registrations. And you can also swap around that on equals sign to be something like on logins.name equals registrations name. Okay, so here we're just generally showing the syntax, and we're looking at that name column. So then we look at, well, where do we have a match in both tables? And that happens to be Andrew and Bob. And so we said select all the columns from these. So that includes the registration ID column as well as the login ID column. So we have these 4 columns, we have the matches, and we join them together to see this result. So this is selecting all the columns from the resulting of registration interjoined with logins on the name column.
Okay. Maybe that is why it is. Email. Okay, maybe that is why it is. This is why it didn't work. Let's see. Oh, let's see. Customer ID. Okay. Let's see if we at least we now know what the syntax and what mistakes we were making, but how it makes sense
and that's
how
it. That's an
used,
inner join.
how it should be
Again, an
used.
inner
I think
join
I'm
is
still
looking for
having
matches that
struggle with
exist within both tables. And here we're saying select all the columns. Notice, because we said select all the columns, the name column happens to be duplicated or repeated twice, because there's both a name in the registrations and the name in the logins. If you wanted to get rid of this duplication, what you can do is actually specify what columns you want. So here I'm saying select registration ID, logins.name, then login ID from registrations, interjoin logins on registrations.name equals logins.name. So you might be wondering, why do I have to specify logins.name instead of just saying name? Well, the reason for that is because name existed in both tables. So we had both tables share a column name, which means if I'm selecting something after a join, I should specify what table I'm referring to in regards to the name column. And in this case, it doesn't really matter. I could have said registrations.name or logins.name, but I should be specifying because there's a duplicate name column. In my SQL query, I should be specifying what actual column I'm looking at. Because recall, here we had both the name column from registrations and the name column from logins. So if I only want one of those, because it's duplicated, I'll specify that I'm looking at logins.name column. Remember, again, that table order won't matter in an inner join. And also, if you see just join without the inner, PostgreSQL would treat it as an inner join. Now, I'd highly recommend that you always type out the full inner join, but some people, as they get really used to PostgreSQL, just use the shorthand of join, which defaults to inner join. Okay, let's go ahead and jump to pgadmin and work through a couple of examples. Okay, here we are in pgadmin. Now, if we come over here to schemas under public, under tables, we can see the various columns that are in the tables. So if we take a look at, for example, the customer table, we can expand the columns, and we can see we have the customer ID and then the associated information with that, such as store ID, first name, last name, email, etc. And we can see in the payment table, we have the payments as well as a specific payment ID and then the customer ID. So what I want to begin exploring is if there was a way I could join the payment table with the customer table in order to get maybe the customer email associated with a specific payment. So for example, I can say select everything from payments. We'll go ahead and run that. Let's put this on 2 lines together just for readability. So I run this and I can see I have a payment ID and then a customer ID, staff ID, rental ID, amount, etc. Let's go ahead and do the following. We'll say select everything from payment and we'll perform an inner join with the customer table. So this is essentially table A inner joined with table B. And since I'm doing an inner join, I'm only going to get back results where that particular customer happens to be both in the payment table and in the customer table. And now I have to decide what I'm actually going to join them on. So I have to join them on a column that is associated with both the payment table and the customer table. And I can see I have this customer ID column, which essentially uniquely identifies every single customer. So let's go ahead and join it on, and then we'll say payments dot customer underscore ID equal to the customer table dot customer ID. And if we run this, we should get back a lot of columns. So we run this, and we can expand on this. And now you'll see I have the payment ID, customer ID, essentially all the information from the original payment table. But if I keep going further, now I see the repeated information based off customer ID, but now it's on the customer table. So I see the store ID, first name, last name, email, address, etc. Alright, now let's see how we can select certain columns from each table. If I'm referring to a column that can only be found in one of the tables, then I don't need to specify what table it should come from.
So this is how it can be very useful, I guess. If I go select let's say amount, and we run this, and customer ID, let's see what happens. So this is a payment ID. We go, okay, so now we can, we can really get creative with this. Yeah, this is cool.
Luckily, PostgreSQL is smart enough to understand that if I refer to something such as select the payment ID column, since that's only found in the payment table, I don't need to actually clarify what table it should come from. However, if I'm referring to something like customer underscore ID, that can be found in both tables. So I should clarify what table I'm actually asking the customer ID from. And since I'm asking for payment ID, I should probably link it to the customer ID from the payment table. So I do this by saying payments dot, and then I ask for the customer ID. And then finally, let's go ahead and choose some column that is unique to the customer table. For example, their first name. So we'll simply say something like first underscore name, and let's go ahead and try that out. Put this.
You know what? Let's get creative with it. Why not? Let's go. First name. This is not actually creative. First name as Why is it like? Why did it shorten it? Like, I don't know. What I'm worried about Peter. That much I can tell you. Like, what exactly? Peter is spending so much money on movies.
From on a new line here. So I'm selecting the payment ID, which is unique to the payment table. Payment.customer ID. Customer ID is not unique to either table, so I clarify what table I'm actually referring to for that column. And then we select first name. First name was unique to the customer table, so I don't need to say customer.firstname. Optionally, you can say customer.firstname and nothing will happen or nothing will change, but it's just easier to say just first name.
Wait a second.
So let's go ahead and run this.
Come right back. sorry about that, people. Let's go.
See the results? Notice now I get to see payment ID, customer ID, and first name. So this is the general syntax that we're using for inner join. Notice how the inner join is only going to join customers that are found in both payment and the customer table. Essentially what that means is by providing this inner join.
Wait a minute. We do this. Let's. Like I didn't know we could do this, but if we can do this, well, let's experiment a little bit, yeah. Select. Let's go. Customer ID, payment dot payment ID. Yeah, this is how it's done, right? Like, yeah, payment dot. Yeah, this is how it's done. And let's go first name, yeah. First name. First name. Let's go. Let's go payment dot amount. From customer table. First name. I don't think this will work, mind you, but I'm feeling like I'm just experimenting something. So let's ask we didn't join in that value also. We didn't join and that created a problem. So if we want to borrow another column from another table, join is necessary. I thought we could just borrow it. Some payment dot amount and proof by when using available function from all. Join the customer in using their formula of this join group by customer failures लॉक क्या काम है मेरे डलवाओगे और दो क्या भेज नंबर दे दो उनको हाँ हो जाएगा Okay, like I think we bit off more than we could chew right now. We will do this. We'll do this by the end of the stream. I'll try to do some of this nonsense again. But I think that right now
I'm not going to see customers that have never created any sort of payment because I'm only looking for customer IDs that are found in both the payment table and the customer table because of this inner join. So again, general syntax, I select columns from a table, let's say table A, inner join on table B, and then on payment.customerID equal to customer.customerID. So table A, the identifying column equal to table B and the same identifying column. Keep in mind, this column could be called something else in the customer table. It could be maybe shortened to just C_ID, but as long as they're referring to the same thing, the customer ID, that's okay. Typically, in a well-designed database, these should have the same column name, but keep in mind sometimes the column name will be slightly different in one table than the other, so it's up to you as the SQL query developer to just make sure join. Technically, these orders don't really matter. I could say from customer inner join with payment, and if I run this, I actually get back the exact same results. And depending on what version of SQL you're running, or PostgreSQL, welcome everyone to this series of lectures on outer joins. So as I mentioned, there's a few different types of joins, and one of the subsets of these types of joins are outer joins. And there's actually a few different types of outer joins. Outer joins essentially allow us to specify how to deal with values only present in one of the tables being joined. And these are more complex joins than the simpler inner join, which is essentially the default join, where you only grab rows present in both tables. So definitely take your time when trying to understand these outer joins, especially when we start talking about left and right outer joins. So So in this series of lectures, we're going to start by talking about full outer joins, which is the simplest outer join, and we'll also add in the clarifying where statements you can add in order to specify what actual rows you want even further. And then we'll go into a lot of detail about the left outer join, which is probably the hardest for beginners to grasp, and then we'll also add in clarifying where statements to subselect rows from a left outer join. Once you understand that, we'll just quickly go over right outer join, since it's essentially
Just so you know, let's ask ChatGPT what is full outer join. A full outer join is a type of join that combines the result in a left outer join. It retrieves all the records from both sides and where there is no match. Hello? एक मिनट नहीं आया ₹1000 आया both tables and where there is no match, it fills in null values for the missing column. So basically, fuck. So
the reverse of a left outer join. And if you understand a left outer join, you pretty much already understand a right outer join. It's just the opposite. But let's not get too carried away. Let's begin with
left outer join in SQL. What the fuck? A left outer join in SQL, often simply called a left join, is a type of join that retrieves all rows from the left table and the matching rows from the right table. There is no match in the right table and the result will contain null for the column. The left table, the matching rows from the right table. Includes every row from the left table in the result. What the fuck is a left table? What is a left table? The first table up.
a full outer join. So let's start with the full outer join. Now let's review the two example tables from the previous lecture series on inner